What's up, YouTube? What's up, YouTube? So we're gonna go for a full screen share here. Bang. All right. The one thing I forgot to do last time was today. Thank you, Aaron. All right, we're live on YouTube. Let's go. Substack. Start live on Substack. All right. I appreciate everybody from last time. The few views that we did have, we're building them up. I'm excited about that part. So that's awesome. Now let's go live Substack. All right, we're live on Substack. Screen shared. Well, good morning, everybody. Huh. That's wild. Okay. So I guess we just do it this way? I don't know, it crashed, so. Huh. Wild. I guess we'll just go live then, huh? Let's try to pull up just to give it the title at least, right? Must have been too many people coming in at once. Something. Try this one. Oh, no, we're down here. Okay. Oh, wow. Sorry, guys. It did some weird stuff from me. Okay. Yep, just trying to figure it out as I go, I guess. So, welcome. And let's see what we're doing. All right, we got all that. And I guess we'll just be off to the races. That kind of sucks, but I guess that's just what it is, huh? All right, great. Well, yep, this time I got a full screen share here. So hopefully y'all can follow along a lot better than the last build session. Sorry about that. Hope y'all are having a good morning. We'll wait a second, I guess. Let a few more people come in just so that we're not starting right off. But hope you guys are having a great morning. I know that I am. So what we start off with is we're going into the next slice. Let's see. This will give us an opening statement. Gave me an opening statement. We're doing slice 16 commits tonight. This is where the AI web operating system becomes approaching outward expression, it's also where it could be very easy for it to accidentally collapse meaning into authority. So we're going to move carefully. Selected meaning is not truth. Readable output is not proof. I don't know why I'm wearing this. And fluent output is not authority. Echo validation is not delivery. And understanding request is not doing the request. It'll only accept the exact scope that survives the evidence test, refer decisions, records, and commit fully recognized. So give you guys an overview of what we're really doing is we're completely eliminates the need for an LLM, which completely eliminates a lot of the confabulant hallucination that most of LLMs do. It's going to be an input output, so it's going to take words, put it into manifests, and then it's also going to take from the manifests and turn it back into words. So that's the whole point of this. The way that I start, I have primer prompts that I always start with. So at the end of our last build session, I did an overview of what we're going to be doing next, an overview of what we just got done. And so build 5, and we're going to schedule a stream for tomorrow. That's this one. Good morning, everybody. Then we take our primer prompt at the end of that, and we send in, okay, write a handover prompt. In our last session, I sent you guys this prompt. If anybody wants this exact prompt to modify for what they do, more than happy to send it. So then this is the complete handover prompt that it gave me. So we'll take this into a brand new chat. Paste that guy in there. And then we'll add some of the files that we need for it. And then what will happen is it'll end up telling us, there you are, Aaron. So we haven't gone too far into it yet. I just did the primer prompt from the previous build session. And first things first, I want to give it the main packet. This upload to GPT AI Web Language. This is the core master packet. This is where most of the information is. And again, I put everything. We send packets back and forth in tar GZs. And what that does is it's even more condensed than a zip file, so that there's less information that has to travel back and forth, and then it can just unzip it and read into it. So we'll send that guy. Then we come here and send the last files that we made, which looks like there's 4 of them. Let that guy go in there. Got this guy going in there. 2 more to put in. And these are all from my downloads folder that are on my computer. So none of these are saved into my actual Google Drive, because that's usually where a lot of my papers, as you can see, a lot of the papers that I have it pulled from are in. I put that one in there. And then we'll just put it in again, I guess. I'm not sure if I put this one in there yet or not. So we'll come down here. Bang, bang. Morning, Aaron. Yes, says that it's 11 here, but my computer says that it's noon here. So, and since I scheduled it on my computer, I guess this was what I think that you're right, and for some reason my computer went to a different time zone. Either way, here we are, and I'm glad that you made it. So, yep, so now we'll start this first one off. That primer prompt is, it's the entire, it basically tells it the next, what I expect out of it, what we're going to be doing, and where we need to be going. So, no, because I think if it was on Michigan time, I guess honestly, I don't know. I didn't take the time to think about it enough. I just saw that my things came up, so I logged in because I thought that I was wrong. So, but as you can see, we're also using 5.6 Sol. And I don't know if you guys had a second to play with that. I was playing with it last night a little bit. And it's actually quite awesome. I don't know if they're called tools, but we threw in 3 or 4 new tools. So now that's what we're going to be seeing right here is the tools going to be being used. They're custom tools, so that's awesome. Kudos to OpenAI for that. That was something that I was bugging them about being able to do. I don't know if it's a new thing, but I just figured out that it could because it put it right in my face. So I'll start right on this. And before we really get started, is there anybody that has any questions about anything, or even just a good morning from anybody, anything like that? Anything that anybody wants to chat about real quick before we really get into it? Well, good morning, everybody. So it says I got slice 16 committed, state pack, it's inspected record and checksums. Okay. Yeah, okay. Just wanted to make sure that I was sharing my screen again, because for some reason, I don't know if any of y'all saw it, but I had to restart the stream. So, one important and it makes nicely clear, no sub-17 yet, and verification. Workflow now, because the stage is evidence inspection only, it requires me to validate the supply checksums, closeout records, and commit state package without repairing or accepting anything prematurely. The controlling profile is Forge RMC, the high architectural sensitivity, the slice 16 on the mean section boundary. Check the files. One important defect has surfaced. The old slice 16 packet. Every ordinary internal hash validates, but the internal checksum manifests include a hash for itself. So that one entry cannot validate. The file manifests. I'll bet you that's what happened at the beginning of the last one too. Also admits checksum manifest file. The archives external checksum is correct. So this does not indicate the archive change after delivery, but it means it will not describe its internal manifest as fully valid. Checking whether the actual source, test logs, verifier logs, and repository metadata remain mutually consistent despite the package flow. So what I'm assuming it's going to do is then have me, we'll open up our terminal right now. What it's probably going to do is have me send it a packet to get it updated on everything that's on my computer, or at least the things that matter to it on its computer. Language core archives, safely shaped, one top level directory, no absolute pass, no traversal entries, and no links. Finishing narrow integrated spot check. Here we go, off to the races, y'all. So let's shrink this up a little bit. Make this guy over this a little bit. Alright, so section 16 checksum, slice 116 test verifier logs, code, all record files are empty, slice 16 commit. exported. File this matches. No frozen rendered or connector attribution shown. Found a package defect. So before we articlerize it, this guy. Status check show anything, a branch that differs, stopped, and everything the rest. So what we're looking for here is it to say git log clean, I think. Oh well, let's ride the wave, see what happens. Origin name to report product source. So we take all of this, and give it that information, and we roll. No, we're developing the language, the linguistic architecture right now. Aaron asks, "Are you developing the Forge layer right now?" Technically, yeah, because Forge is the whole workbench. So within that workbench, instead of using an LLM to make deterministic or any type of call on what it says or any type of meaning on the definition of what you're trying to get at, we're taking the LLM right out of it. We're not going to have any, like I said, that'll actually help with and hallucination. So that problem we won't even have, it's not even going to be an issue with Forge. It's also going to be bidirectional. It's not just going to be input, it's going to be output generation as well. They're both unrelated systems, that way they never cross over, and there's no confabulation from what you say into what it manifests, and then from what it manifests into the output of what it's going to do, whether it be text, code, music, art, whatever the output is that you're trying to get out of it or with it. Creator cases, Grand Rising, and a lot of info. Yeah, I know. That's why I can't ever have a small idea, and I always trace it right down to the bottom of the rabbit hole. Unfortunately, that's the way my brain works. If there's still a question, I have to answer it. So if I am going too fast, be sure to ask questions. I'm more than willing to slow down a little bit so that everybody can see exactly what we're doing. I just want to make sure that the screen's still sharing the way that we all would accept it. So now it says live pre-flight passes exactly, correct repository, exact slice 16 head, clean working tree, and expect untouched commit stacks. Now building slice 17 source packet command around the real track path evidence, include a corrected manifest design so it does not repeat the self-checksum defect found in the older packets. So then let's see if I can show you from here. I'm not sure how. Let's see. So it's not actually letting. Okay. I was going to show you the tools that I made this morning, but I guess we can do that either at the end or if anybody's actually interested. Yes. Aaron asks, does the RMC replace the LLM? Yes. It replaces it because you can't. So the whole point is to be able to go back and be able to know why it made a decision and be able to audit its decision making. So That way, because in an LLM, you, like this, I don't know why it is saying what it's saying. You know, especially for somebody who doesn't explore, doesn't have the time to explore how LLMs actually work through the transformer architecture. And there's nothing wrong with the transformer architecture in general sense, but if we want doctors, law enforcement, judges to be able to rely on something like this, because unfortunately, or maybe fortunately, this is the way that technology is going. We definitely want to, as a species, we definitely want a way to track why it came to a certain conclusion. So within the Forge itself, yes, we're going to be replacing the LLM. So let's track project paths and packet generators large enough that pasting hundreds of lines to a live terminal would create unnecessary error risk in packaging the exact auto generator to standalone script with its own checksum, then give it short verification and run command block, still performs every square. We'll see what it says first. I was gonna say if it needs to make a packet file for me to download and run, if that is going to be easier, but we'll see what it says first. That's usually the easiest way, is creating a packet and then uploading it, just like all of our other ones. Back to roadmap. Okay, so it's under. Right now, I'm just trying to find where all of our like guide will be for building this. So we'll start. Let me grab the right Google Doc. I thought that I had it open already. So let's see. I think that's it. This so I can actually see. Plain language build. There we go. That's what I was looking for. So this is kind of my guide for myself to know where we're at and where we're going, so I don't get lost in the architecture myself. So we are on slice 17 right now. Output expression boundary scaffolds. So now download these two files. See it already did it. Look at that. So we download these. Oh, it's gonna make me, okay, that's interesting how it does that now. And then download that guy. That guy. Go. Then open the terminal and run this. Then expected results for packet checksum 781B981. Yep. And passed. So we run it now. And what this generator will do is it'll reconfirm. It'll copy track source authority, preserve all slices 1 through 16, all the packages, test verifiers, and guarded evidence, and capture expression, refuse to continue a test fail, create a corrected portable internal checksum manifest, and create the source packet and external checksum in my downloads, and then leave the repository unstaged when committed. So once we read this at the end, it'll create these two files right here, and then those will be the two files that will get it up to date on where we need to build from. Alright. So, yep, slice 16 confirmed. Let's just take a quick look through here and see if anything looks weird. Everything says okay. Here, evidence memory, extra resource quarantine, annotation, requirements. I'll read. Yep, all of our slices, 116, 116. There it is. Alright. So we go here, upload those two files there. Bing. Bang. And now we're off to the races, y'all. So it's been really cool the last couple of days. Actually, yesterday I took a half a day off of even looking at a computer because my eyes started going cross-eyed. So I figured that was a good time to go outside, and I went swimming. I went swimming for the first time in Texas. Okay, let's see. Slice 17 source packet checksum here, treating them as the next evidence gate only. Turn external checksum, archive safety, correct internal manifest, clean ahead proof, full 1 3 or 116 logs, frozen boundary scans, and exact source coverage. No slice 17 code will be designed unless every required source authority check hold. Says gate passed, got the right checksums, and archive has one expected root with no absolute pass. Traversal entries, links, caches, or beta code. Moving inside the packet now. This is where the earlier self-checksum defect was proved corrected. Now it's been inspecting the packet for us. The correct internal integrity design looks exactly as intended. Not every non-self packet file validates. Complete file manifest matches all 293 members, and portable sources hashes all paths after extraction. Clean state evidence is empty before and after testing. All 16 behavior tests and all 16 independent verifiers passed without an empty STP error. And now it's now checking whether it include code implementing structures. So now it's going through everything. It's going through everything deeply now to find out where we lay this next slice on top of and how it actually bootstraps into it. And I think that's the best. The best way, obviously, is to do it in what I call slices. That way, it's all of one thing, and then you bootstrap them together. And then if something messes up, you just roll back that last one, rather than having to go through your whole code and figure out why it did what it did. Source boundary has appeared. Pausing the slice 16, 17 design decision around it. Packet full repository frozen scan. Found live track files outside the copy source. Contain imports of the frozen render connection. Yep, it's all that stuff. Remember last time I was talking about how it would keep it in there, but we weren't going to delete it. Reachable legacy evidence, guarded code or actual boundary violations on inventory of the execution expression. Bring paths now so the follow-up packet is narrow and complete. Source packet is not yet sufficient for slice 17 design. It approves new scaffolding baseline, but the repository already contains substantial legacy current rendering surface. The full RMC engine version 1 renderer general pipeline code, all the evidence record, and live. Yep. Now see, this is why I wanted to stop where we were at and start here, because this is actually where the our GPT-014 or GP-014 was where we actually found out that using LLM through a deterministic. So what we did was we started it, when we built it, we started it with just math, so that it could do math, make it into a manifest, and then come up and give us the final output. But what we found with using an LLM into a manifest is that the LLM started adding its thoughts and why. So it was making manifests that had information in it that it didn't need to have in it. So that was the main cause of actually coming up with this research order to get a general deterministic non-LLM bidirectional language architecture. That was the whole thought of the start of it, and now it has became its own little project, which is cool. Really too. That's really cool. That's amazing. Ian Meyer, Bianca Schultz, Francesca, Mind Vision, Brenda, all y'all. And Jay, appreciate you. So, library file with specific assets. So, after we get done with slice 17, which is why it's taken so long, because we're actually removing something and putting this all in. We'll be going to the preservation wrapper decisions. Ian Meyer says, "My pleasure to be here." The pleasure's all mine, my friend. What it'll do is we'll be going into the wrapper decision slice. It'll preserve GP-014, which is a patch. That's what we're calling the patch itself. Whether it's wrapped, referenced, or left isolated, wrap it. All right, here we go. Now we're talking. So slice 17 source packet itself passes integrity baseline verification, but the decision is currently blocked. That's exactly what we want. Doesn't mean slice 16 failed, the repository is dirty. It means the packet's uncovered relevant live source that it did not include, specifically the full repository scan found frozen modules imports to main or authorized yet. And we're going to download the supplement generator. It's going to basically do the same thing, but now it's doing it on a narrower path to actually find out why. So verify the generator is there. Consistent authority. Yep. And then we'll generate the supplement packet. Paste this and capture the main PY. This might take a second. Our main Python. Oh, look at that. Actually, really quick. Run through it real quick here. Let's see. I just saw it. Main PY, yep. There it is. There's a main Python. That one's kind of ridiculous. And if you go on GitHub, you'll be able to find it. You'll be able to find most of the stuff RMC that we're building. Generate supplement successfully ends. Yep. And then I'll let it know that it passed. rolling. So, let's see. So this might also be something cool. So how it works is going to go from the knowledge ingestion layer. It goes to the source to semantic compilation, the semantic memory lexicon growth. So when you start uploading your own files into Forge, whether it be books that you wrote or things that you're interested in, what it does is it breaks all those down and saves those in the ingestion layer. And then it'll actually link it up to your identity vault so that it knows exactly what you're talking about. So if you reference something, you don't have to have it search through your Google Docs or your Google Drive. It'll already have a reference directly to it. Then it goes into question and answering, or question understanding. So it understands the question that you're actually asking and puts it into a structured problem request. Then the MEA problem manifest creation. It identifies known facts, unknowns, goals, constraints, source ancestry, permitted tools, and claim requests. Then after that, it goes into frequency-based symbolic calculus, manifest, algebra, execution, and it generates and verifies candidate solution paths throughout the actual operators. So that's what I was talking about, how it would create different manifests, and then you choose from which one you want, so that it doesn't have to be completely deterministic. It can also be evolved. So over here, complete at the correct clean head with runtime execution explicitly absent. Resuming the block source and inspection gate now. First, validating the archive and manifest, then reading the live import context and existing GP-114 rendering echo contracts. Determine whether slice 17 may proceed or needs containment first. The supplement internal integrity gate passed, including all live routes for the RMC engine version 1. Files and the target script evidence, and it's tracing all the questionable imports end to end, definition, seller, route exposure, guard condition, and side effects, because the mere import statement is not enough to classify the path safely. Then after it inspected, it went to the import trace resolves and ambiguity. There's not merely dead strings, the live HTTP routes calls them. The frozen model failed closed, so they do not currently reach an LLM or Chroma, but the live runtime still imports and calls them. Still advertises optional Chroma backends that contradicts the control of frozen evidence only, no imports or call off. So checking the separate deterministic GP-114 non-LLM path now, so the final ruling distinguishes the protected baseline from the contaminated compatibility paths. Extracted red code sections from GP-015 and GP-014, deterministic and non-LLM lanes are separable and remain preservable. They're not the problem. The problem is the older optional LLM Chroma compatibility lanes still being callable through live adapters despite its internals now failing close. For the issue, the formal blocked allow ruling, checking the controlled rendering law documents available in project source, so the decision rests both on the actual code and the improved architecture. Get a little ahead of this, subject expression boundaries. So once we get to slice 22, which it's completely possible for us to get there, I knew that this slice 17 was going to be like a hinge on how slow or quick today was going to go, and I'm glad that it's taken its time on it, because this was one of the parts that I was kind of worried about. search through everything. Architecture check confirms the precedence clearly. The old RMC paper allows an optional render principle, but the later approved implementation roadmap makes the Forge RMC non-LLM boundary absolute, including expression generation and hidden fallback behavior. Completed the formal source inspection record with a blocked outcome and exact smallest corrective scope. Perfect. So we'll also grab this to open this up. And thanks to my co-captain Aaron here, the skin document, which multiple ways. It's almost like a beginner's apprentice packet, because with somebody like me, I have there's just so much that I want to explain that I brought this up. You need to use the KISS, the KISS treatment. Keep it simple, sweetheart. So that's what I'm trying to do, is figure out how to make it more digestible for general audiences, because the whole point of Forge is that you don't need to be a coder, you don't need to be some with Linux. All you need to do is understand what it's doing, and sometimes that's hard when I want to get into why it's doing what it's doing. All right. Yep, Aaron says it's a Cliff Notes version. Exactly. So we got block slice 17 patch design is not authorized yet. Slice 1 tests verified pass. No evidence that an LLM chroma is actually being reached. Frozen modules fail closed. Problem is architectural truthfulness. Live HTTP routes in main still may import frozen models, calls frozen LLM heavy function before falling back to the deterministic rendering. Memory recaller imports frozen chroma function, static inspection. RMC version 1, GP still describes optional LLM control capabilities. 2 legacy tests still directly import those frozen modules that violates layer controlling law, and specs must not be imported, called activated trust or RAP. GP-014 non-LLM rendering paths are separate and the main package here. Architectural documents, everything passed. Control and then flex inspection packet. And then the next safe action is a separate read-only frozen call site contamination or containment patch design record. That design will determine exactly how to remove the live capability imports while preserving file system recall. Determine GP-014 and frozen boundaries. Authorize that design, please reply. How about we reply, please? So one thing that we're really trying to do with doing these live builds and putting it out and having everybody be part of the actual build itself is that if anybody wants to get involved, this is ours. This is not mine. This isn't going to be sold. This is going to be completely open sourced for anybody to run, to use, to build, to break, to do whatever they want with it. Like this is designed for everybody. So something that people can help with. We've got contribution roles. Everybody who plays a role in building this and building this open source to get it to the point of where it is where it's usable, where it's usable for general people, where we can use readers, editors who want to do testing once it's finally at that point, apprentice people where they study the protocol purpose and practice of AI Web over time. We need reviewers, economical protocol reviewers, live build observers, which are all of you, and I'm tracking all of you that are here with me. So all of you guys will actually have contribution in just from being here and watching. Contribution tokens once this all opens up, just from watching, just from being here with me. Documentation helper, future Genesis node operators. Those are just the contribution roles that we have came up with now. That's very skeleton. So if anybody can think of other contribution roles that we can add to this to help expand this into reality, then I'm more than happy to talk about it, get it figured out, and see where you fit. Because like I said, you don't have to be a technical AI expert in order to run Forge, or in order to use Forge or modify Forge. So we'll go back, design phase is authorized, keeping it read-only, resolve the exact touch file list, and compatibility behavior now, especially auto-preserve deterministic output rendering, and restore default file system recall while refusing every legacy LLM or Chrome toggle. The design will include backup, rollback tests, independent verifications, and explicit non-goals, but no patch payload. Perfect. Then inspect the code, and then it's one last source gap surface while reserving the exact design. The supplement scan prove that scripts test RMC Chroma connector, imports the frozen Chroma module, but that file and the paired 15 to 16 historical pre-flights scripts was not copied into the supplement because the authorized design must name whether those files are modified or retained as historical evidence, not guess their current context, narrowing the missing set into a tiny final evidence packet. Great. So now after we get all of these evidence packets and all of them uploaded, it'll be able to really know exactly what needs to be, what doesn't need to be, because this is a fresh chat. So it didn't, like right now is when it's learning that all of those that were in there were just in there for legacy view, but it also found that in the HTTP UI, because there's actually 3 different layers to it. We won't get into any of that right now, but there's 3 different layers to it, and the HTTP one is the middle layer. So it must have been all we were looking at was the Ian Meyer. Grateful for your vision and generosity. Says he's in for whatever capacity you can. Best thing to do, I know it's not a final version, but the best thing to do would be to, on my Substack page, if you scroll down a little bit, I know it's probably not at the top now, but if you scroll down a little bit, you'll be able to find this beginner packet. If you start reading this beginner packet and you get lost in the beginner packet, because Aaron has created a Cliff Notes version, and I can send that to you as well. Like I can send that directly to you, and that might be a little easier. This is as broken down as I could make it for now, but this is a live modified. But I appreciate it, and you let me know what capacity that you want to put into it. So, or honestly, so now we generate these files again, these generator files. And verify the generator is there. Expected. Check some 71P 981, 71P 91, yeah. And then now we generate just this tiny supplement, and unless it finds something else, did not commit anything, upload, let's see, external. successfully output 71B, 71 E9, FP6 F15C, FP6 generated. And with this work here, you can really create any type of app. You can create anything. Like this is the easiest type of workflow, and because we're sending direct files, we're sending condensed files. That actually makes it so much easier. Now we take this here and we upload it, let it know that it passed, and we let it do its job. Give it a reload. So I must have somehow. So just put it in again. Must have pressed it twice. And there's that. And then there is. Upload it. Yeah, that's better. I must have hit it twice. I triple click. Welcome to everybody new to join. So let's see. Let's run through this real quick and see what this made for us. Repo state, got all that source script reviews, patch pre-flight, and source script test RT from connector. That's what we're actually really doing here, or on this one. Okay. So we'll go back to the restrict order, kind of give you. So what we're trying to do is we're trying to build Forge. It's future language core and general purpose deterministic non-LLM systems capable of compiling human language into governed internal meaning and compiling governed internal meaning back to a controlled human readable expression. So our whole goal is to make it general, deterministic, non-LLM from entry and authority separated. So that it can be proven before it expresses what it's trying to say or what it's trying to do. Because Forge won't only express in language; it'll also express in code or sound. Even is what we're working towards. And there's, like I said, I go into a lot of it. If I go into it too deep, and if I'm going too fast, make sure to let me know to slow down for sure. Now we're thinking hard, huh? Oh, that's why. Okay, so we'll just bring it down. Apparently, let's see. Now switch it from here. Usually just let you switch it from here, huh? Huh. Would you look at that? That's why I did it, huh? Okay. Sets at 4. Okay. Well, there's egg on my face, huh? I guess we should have just kept with the original model. We'll just go to that guy. Huh. Oh, I'm definitely not upgrading. It's because we're in work still. Sweet. Alright, well, this is how we solve that problem, right? We take all of this. This is why I love doing live builds, because then you guys can see the problem solving that happens in it as well. It's not just taking a new, or taking what the LLM says and doing it, right? So now we'll start a new chat. Go to this guy. And then we'll copy this. Bang, boom. New chat. Release. Oh, shoot. So that means that I screwed that up. So we'll come here. Here. Still and then this. Do it again. Copy everything that we did. I didn't realize that was still in work, because the work is when I put it into work the first time, it was to build some of the all of the tools or whatever that it said I could build. So put in our first message for the chat. Okay, so basically starting over with a little bit of knowledge, which is fine. Try to trick me, I got you. And then we'll come back down. That way it has the information from before. Upload that one. That's kind of bugging me. Go. This, see if it asks for anything else. If it didn't, sure it will. This. I'm sure eventually they'll want all of these. Start with this and see what it goes. See what it says. Really? Message from reach. Oh. I don't want solve. Anybody else have problems like that? I did not know that what the difference. Because I didn't have. I usually just use 0.5. Effort, extra high. Message not reached. What? Alright, well, sweet guys. I guess the message, I've never ever had my message limits breached on GPT. That's amazing. Well, I guess build session on pause, I guess. But what we can do is we can take the time to go over the beginner's packet, I guess. Let's see. Why does it keep going like, oh, this is going to bother me until I figure this out. Bulk usage, more usage. If you were pitching web to AI to a venture capitalist for funding, what value creation or efficiency would you be presenting? So the value creation of this would be that you own all of your own data, that you own all of the things that you build, and that you are actually the true owner of your memory and what you can build with it. So you're going to be able to build apps, you'll be able to build programs, basically everything out of this, and you will own it. You'll own the memory. You'll never run into a time where you run out of tokens. Like, that's kind of ridiculous. That was the main reason that we were using ChatGPT, is because it just lets you build without getting in the way. And at this point, if this is how it runs, we will definitely be switching to a new one, a different one. So let's try it like this. I want to try it like this. Wow, that's wild. That's really wild. So now it's got me all off, because that's what the whole point of what we were just doing today. This wasn't supposed to be a roundtable about what AI.Web is. It was supposed to be the build, right? So let's see if we can. Well, I guess we'll just go over this beginner's packet then. So the build direction public path is being built live, trying to build it live from local prototype AI.OS running on the builder's machine towards a beginning safe public system that other people can eventually download, run, study, test, and customize. The intended public direction is that, so it starts off with ProtoForge. ProtoForge is the foundation layer. It's actually where it's a place that stores the memory, logs the commands, it tracks all the drift, enforces structure, and refuses fake success. The ProtoForge is not the public product by itself. What it is it's more like the lab bench itself. It's the memory rack, the safety harnesses, the trace logger. It's where the system learns how to not lie to itself. And then sitting on top of that is actually Forge. That is like the actual workbench on top of ProtoForge. It's the local operating layer that it's the actual console. It's where everything's actually ran out of, where you actually interact with all of the files, and it lets you read documents, search the corpus, inspect code, propose patches. It helps you with the pre-flight changes, verify results. It helps you visualize the rollback safety and run structure simulated through a controlled interface. So it's basically ProtoForge holds the foundation, and Forge is where the builder actually works. And for the Gilligan public system, this I found out is one of the more confusing parts of it, And I think that it would be better to break this down into why Gilligan was built, or why this system was built. It's actually part of the living symbolic memory structure, and so it's your agent. It's the agent that you basically grow from. We'll use the term baby, from a baby into an actual usable agent that is built specifically for you. It's where the class conditionals and the actual core injection is, like from who you are, what your ideas are, what you're feeling that day. Even it'll be able to track all of that. As the echo handler, drift containment, it interlocks with two other agents that are going to be an important part of the system, which I haven't introduced yet, because they're not too important to the core of Forge. But we'll have Athena and Neo. Athena is going to be the one that's in control of all of the contributions, and the more how would you put it? The more the person, like basically the one sitting behind the desk that's doing all the movement of the important tasks, and then Neo will be the one who will interact between nodes. So it'll be the exchange between nodes. Gilligan will also help you store your ghost loops. What your ghost loops are basically your thoughts that haven't, like the ideas that you have that then end up becoming put on the back burner because you went to a different thing. I know I have that problem all the time. So or if you're writing something, you just want to get an idea out. You get the idea out. It saves that idea. Doesn't delete it. It still stays there. But so with Gilligan, let's see. This is like the whole codex to him, and this is available. All of these, pretty much everything is available on GitHub, over and at GitHub, and that's where you can find most of the library. But again, if you start off with this apprentice packet right here, and you get to the end of it, once you get to the end of it, it actually gives you a good library breakdown of all the books where you can find the sources at, and it'll give you a better idea of, if you wanted to go deep into each one, whatever part interests you the most. And so here is, so like I was trying to explain, Gilligan it's the deeper agent architecture material. It should be handed to beginners as the first explanation. It should be used by builders, editors, to extract public patterns clearly. And with Athena, it belongs on the agent governance and reference shelf. It's useful for understanding administrative investor site and the chatbot governance directions. It shouldn't be the first beginner path though. And then Neo, it'll be included. It's the public facing agent, and for now we'll just kind of keep those as references. For there's obviously more than one agent, and you'll be able to spawn your own agents as well. So whatever you need an agent to run a task for, you'll be able to spawn and own it, and then that agent will be in your identity vault. So we've been running for an hour now. What we're gonna do is we're gonna stop this stream. I'm gonna either figure out how what's going on. I mean, obviously I see what's going on. It's saying my message limit reached. I've never had that problem, but I'll figure that out, and we'll either upgrade or wait till 4 o'clock. So if you don't hear anything from me until 4 o'clock, we'll be back live at 4. So I appreciate y'all for being here. Hopefully you guys join at the 4 o'clock session again. If I can't figure out what's going on with her, and we'll keep on building. Team Humanity. Out for now. And YouTube, I appreciate you too. Even though I don't think anybody showed up on here, I still appreciate you for keeping it for posterity. And we're going to end the stream here. Peace out, y'all.